I'm going to show you how to connect a continuous rotation servo motor to your Arduino, which is great for projects where you need the servo motor to spin continuously in a single direction, either forward or reverse, and where you need to be able to specify the speed that it's spinning. So, for example, this is especially useful in robotic car projects. So first I will show everything wired up and working. So here we have the Arduino connected to my computer over USB, powered up. We have the servo motor connected to the circuit components, and we have a 12-volt wall adapter wired into the circuit. And before I connect the last wire, this example is just going to show the servo motor spinning forward for 1 second, pausing for a second, spinning in reverse for a second, and then pausing for a second, just to show some basic control over the servo. So I'll add this last wire to the D2 pin. And we see the servo spinning as expected. So now we can take a quick look at the wiring for this circuit. So we'll see here that the control wire on the servo is connected to D2 on the Arduino. We'll see that ground for the servo is connected over to the Arduino's ground, and that the ground connection is also connected to the ground of the external wall adapter. And over here, it's connected to the ground or cathode of both capacitors and the ground pin on the voltage regulator. Then we'll see here that the 5-volt input power line to the servo is connected over to the output pin on the voltage regulator, and that connection is also connected to the positive or anode terminal of this capacitor. And lastly, we'll see that the 12-volt input from the wall adapter is connected to the input of the voltage regulator, and that's connected over to the input of this capacitor here. And just very briefly, I want to point out that the servo motor is powered from this external circuit connected to the wall adapter, rather than connecting it directly to the 5-volt pin on the Arduino. And the purpose for this is that the Arduino is only able to supply a limited amount of current. I think it's up to roughly 0.4 amps. So if you're drawing anywhere near that amount, you'll want to be connecting and powering, for example, in this case, the servo motor from an external wall adapter. All right, now we can take a look at the code for this project. So pulling up the sketch, we'll see first of all that we're using the Arduino's built-in servo library. And we'll see here that we're specifying the digital pin that the servo control wire is connected to. It's D2 in this case. And we're specifying the initial speed and direction for the servo. In this case, 90 is stationary. So the servo is going to be stationary to start. And inside the Arduino loop, we'll see here that to start, we're going to move the servo full speed forward, which is 180 for 1 second. We'll pause the servo for 1 second, 90 again is stationary. We'll spin the servo in reverse for 1 second because 0 is full speed in reverse. And we'll pause it again for 1 second, and we'll continue this pattern in a loop. So we'll go ahead and export this code from Cirkit Designer so we can import it into the Arduino IDE and program the Arduino. So I will save that to my desktop and exit out of Cirkit Designer. And then here we have the folder that I just exported. So I can open this up in the Arduino IDE. Okay, we see the sketch. So before programming the Arduino, we just need to double check, first of all, that the board is specified as Arduino UNO. and that for the port, we've also selected the port connected to the Arduino UNO. And we can go ahead and compile or verify the sketch. Upload it to the Arduino. And we now have the servo spinning as we showed previously.